Part of what makes ATOM fun is just flying over the open ocean, and it's interesting just to see how, we're trying to sample chemistry in remote regions, but when you go on these flights, you really see that there aren't many places that humans have not yet impacted. We live and breathe in the atmosphere, and even though it seems quite inert, it's a really dynamic medium, and there's a lot of chemistry going on. So it's just something I've always been interested in. I've always been interested in spectroscopy and how you can use lasers to make these really incredibly specific and sensitive measurements. I'm working on the In Situ Airborne Formaldehyde instrument, which is an instrument that measures formaldehyde in the atmosphere. Our instrument on the plane is literally a black box with a couple of switches. I don't know, it's not that exciting to look at, but on the inside, it's pretty fun. We have an inlet on the window of the airplane, and our instrument pulls in air through this inlet and a series of tubes into our detection cell where the laser passes through, and then the formaldehyde in that air sample will absorb photons and re-emit photons, and the re-emitted photons are what we measure and detect as formaldehyde. So we actually count the number of photons, and so on our screen we can read the number of counts per second or per unit time. And if we see the counts go up, it means we have a lot of formaldehyde, and if we see the counts go down, it means we have less. So when we're flying on ATOM, formaldehyde can be pretty low because we're flying over kind of remote open ocean. But when we fly into to air parcels that are continental outflow, we'll see elevated formaldehyde, and this can be from biomass burning or from any human-caused activity. So formaldehyde is an indication of oxidation chemistry, and we care about oxidation because it will tell us, let's say, the rate at which methane gets oxidized, and methane is a very potent greenhouse gas, and we'd like to be able to better understand methane's lifetime as